Hello, everyone. Welcome back to another episode of Turing Complete, or completing Turing Complete, as I now call it, because it's getting a bit confusing with the game and my mod. I am here to do some more puzzles and do some more redstone. Unfortunately, today I am on my own. Joshua is really busy, and it's been a while, so I decided to do this one on my own. I have not done anything in preparation for this episode. Last episode, we made a small counter, which is a program counter. And we also made, I think, the 3-bit decoder, but I don't fully remember. Yeah, and today we're doing something pretty cool. Let's swap over to Turing Complete to take a look what that is. Right, so here in Turing Complete, we have access to two new puzzles. We have this one, Registers, and we have this one, Logic Engine. And I think because this one is still before this line, we should probably finish that one. Create a device that can OR, NAND, NOR, or AND two inputs. The third input will be the instruction. An instruction is just what we call the number that determines what to compute. Instructions: 0 is OR, 1 is NAND, 2 is NOR, and 3 is AND. Also, you can't move the red components in this level for reasons that will be revealed later. Sure, that's fine. Okay, so as we can see, we have OR, and then any number that is not 0, 1, 2, or 3 is a question mark. Then we have NAND, we have NOR, and we have AND. So that is pretty simple. And then we have the input values that we need to put together. So let's go do that. So obviously we are going to need an OR. This is getting annoying already. So we can AND them together by... I don't know if you all remember this. This is quite a while ago. But if you do this... wait, no. Because we have OR. So if we do this... like that. Now we have... I think if I add one more knot, like that, I believe we have an AND. Yeah, okay. So to get an AND for 8-bit, we're going to have to do the exact same thing. I do have lots of space, that's quite nice. Place a bunch of knots, so I can put one there, and one there. And then connect those up. I'm gonna use other colors again. Very ugly, but whatever. Wait, that was supposed to be purple. Nice. Purple. And into a switch, which is there. There we go. And then I can simply connect these together. Grab the gray wire. Like that. And then I need to select this when both are on. Yeah, it was probably smarter to just use a decoder, huh? Because if I connect these two to a decoder... Yeah, that would have been a lot easier. Ouch. Okay, let's do that then. So let's do that. So now it selects the first one, which I would connect to the switch of the OR. So that would probably go like this. Let's use green for this. Great. like that. Yeah, that's a lot better. Wow. I just completely forgot that I just made a decoder. What is... Oh, that's a disable. Nice, okay. I don't need a disable, so that's completely fine. But anyway, then if I want the NAND, then I select this one and grab this one, because this is going to be a NAND. So I can just move these over like that, and then move that one up to there. This is no longer necessary. There we go. All of this is not necessary, because now I can just bring the green wire down to this switch, and we're gonna actually do that from there. This is so much better. Wow. Then we have, of course, the NOR, which was this one. Yeah, the NOR is this one. Yeah, this is not handy at all, so we're gonna actually swap this around. And move this down to the bottom. And then this one, and then this one a bit further. Like that. And then the last one was AND, so that's that one, which then connects here and probably does this, something like that. Like that. Okay, now just connect the wires back up again. So this one goes there, and is still connected to that, but that's ugly as hell. So that goes like this, break this, connects there. And then the gray wire, which connects there, there, and there. Then I need to fix the purple wiring. Oh, that's interesting. No. Nice. Like that, and like that. And voila. I can move all of this down a little bit. Okay, nice. And now I can move this down a bit more. And look at that. It is beautiful. Okay, let's run it. Very nice. It unlocks more. Yeah, okay, I thought so. It unlocks the 8-bit versions of the gates. Very nice. Okay, nice. All right, let's build this thing in Minecraft. Let's go. So to start off with, we need an input A. And then we need to get started. So, the way we're going to do this is we are going to build a... the same way it worked actually in Turing Complete, of course, because that's the whole objective of this series. So we have two inputs, and then we have our logic unit, which is what we're building. Basically calculate the result for every operation at the same time, and then block it off with switches to make sure that only the correct result is sent to the output. So I'm going to make this one orange, I think. Nice. I'm still fantastic at building. Love to see it. So we're going to start off with... I'm also going to actually... Yeah, we're going to start off by moving this down by 1. So the way we do that is actually quite interesting. Because we can't just move it down normally. And the reason for that is if I do try to do that, then sure, here it works. but then for this one it won't, because this one doesn't connect, because this block is stopping that from happening. So instead, what I'm going to do is I'm going to grab some lime glass, and we're going to place that there, and then place that there, because now, if we do this, I am wrong. I'm an idiot. Yeah, no, I messed that up. Okay, I'm going to place glass like this. So these all need to be replaced with glass. There we go. Because now, this one connects down to that one. And I believe this still works. Yeah, it does. Nice. And then this one reaches down to that one, which also still works. And they are independent, which is very nice. So I can just wire this up now. And now it is a block down. Independent. Okay. Because now I can pull this through. And this is going to kind of look like Little Box a little bit, if you guys remember that puzzle. Except now, instead of having different registers we store the numbers to, we have different logic operations to perform on the numbers. So in the same way, we're going to have to bring the signals through. So in this thing, you can see that the input, which is this line here, this is the input, travels off in this direction, but the output coming from each layer, I guess, is this color here, needs to go through it. So to do that, to make that happen, we can place repeaters like this, so that the signals can pass through each other independently. So that's exactly what we're doing there. So I've moved the green layer down by one block, so that when I want to move it over, I can just move it through, like this. And the only way to make it work is to also have repeater there, because otherwise it's not going to work, and there. Otherwise, they will not be independently powered, and it's just going to break regardless. So we're going to do that. The downside of doing this is it adds a lot of delay if you do this a lot. So, as I showcased in the last episode, when I built that thing, or had built that thing off camera, that thing is insanely slow. And the reason for that is because it just takes that long because of all of these passing through signals to make sure that it works. So we're going to pass the signal through like that. And then we can pick up the signal like this. If I quickly just... 8 bits is a lot. 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Excellent. So that's like that. So now if I power this one, as you can see, it ends up there without powering this one. And I can power this one, and it just travels through independent, which is very nice. Now, we're going to build the first operation that we want to be able to select for, which I believe was OR. Yeah, if we enter nothing, then we should OR. So, the way we do that, obviously, is just by combining the signals together. So, we can just bring this up by a level again, which I will do real quick. And in this case, we need, again, this block to be glass, I think. And then this block to be wool. Like that. Yep. And then I believe if I now power this... Yeah, nice. Okay, great. Same deal. So because this is glass, this can travel up by one block, but this one can't travel up by one block because of this block, which means that this one is now connected like that. Yeah, of course, the torch powers the... Yeah, nice. Smart. If I power it normally, like a normal person, then only this one is powered, and only that one has an output. Like that. this is a very useful redstone wiring trick. Okay, now they're on the same level, so we can bring them over. We should probably make sure that these are signals that are like not going to backpropagate, because that would be rather unfortunate. So the easiest way to do that is, of course, just by placing repeaters like this. Which again, more delay, but that way we make sure that the signals are correct. Otherwise, the green signal might connect to the orange side and make other units also think that the number that orange represents is a different number than it actually does. So now we can combine these together like this, and then this is the result. So we're going to just do that everywhere. Okay, nice. So that's the first one. Super simple. Now let's move on to the next one, which was NAND. So, in the puzzle, of course, we could not just use a NAND gate. However, this is Minecraft, this works differently, and I get to do whatever I want in my series. So I'm just going to use NAND gate. Oh, love how fast that is. Okay, great. Now let's make a NAND. The way you make an AND, of course, if you guys remember, was this. With this being the output. The problem with this is that that doesn't fit. So we're going to have to find a better version of that, because that's not going to fit given how closely this is all stacked together. The way we did it, of course, in Turing Complete was the double knot into an OR. So we could probably do that. Like this. And then knot them. And then OR them together. Which would be like this. I feel like that works. It's not a super elegant solution. It's also a bit slow. But it does work, I think. And then we can just OR them together and have an output. Like that. So I'll just copy this again. There we go. Stack that down as well. And there we go. Now I believe that that properly NANDs. Let's move on. Because now we go to the... What is it? NOR? Which was just OR and then not the result. Which is super simple. So I'm actually going to just see if I can steal this. Take from here until there. And I'm just going to /s copy. And then I'm going to have to... how much space did I put in between two blocks? Okay, so then 1, 2, and then this is where it would start, so I need to be there. Right here. I think. That should work. Undo. right, I need to be right here. Nice. Okay. And then we need to do again. Translate all of these through. Now for orange, we don't need to be worried about the signal running out because the signal is getting refreshed every single time we pass the green signal through. The problem, however, is the green signal, because now I think 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so let's put a repeater there so that I think if we power this lever, yeah, that still makes it. Only just. Nice. Okay. Good stuff. Gonna, again, just move this, stack that down. There we go. So, secretly, we are going to be, we're actually also even going to use these here. That's a bit more compact. Secretly, we are doing what we need to in Turing Complete. It's the exact same situation. So, yeah, I was just a liar. Okay, now we just need to not both inputs and not both outputs. So we're going to, again, grab the wand. There we go. And then we're going to have to grab until... yeah, this block. And then again, I'm going to... let's just copy. And then I'm going to... like that, I think. So let's just paste. That should work. No. No, that does not work. That's bad. So let's just undo. Paste. Much better. Okay. And then we need to wire again. Now this should make it, so that's completely fine. Love the stack command, that thing is a beast. There we go, 1, 2, and then go back here. Stack 7. There we go, now everything gets inverted, and all we need to do is invert that again. So we just need to not break that tends to help. Like that, and break these intermediate ones. There we go, and then not the result. Okay, and all we need to do now is grab some purple wool, I guess, if we're going to just stay consistent. And we can just grab an output. So I'm just gonna do this once. Oh wait, no. We're not quite there yet. We're not quite there yet. Because now we have the output. All we need to do is select which one we want. So the easiest way to do that is probably by just doing this and then having 1, 2. Let's use another wool for that one. I feel like this is not the right place. Okay, now the way switches work, of course, is by having these. Like that. So I'm gonna quickly, again, copy paste that. there, so like this. Yep. And then same deal, not here, there, so here we paste. Okay, nice. And then all we need is a bunch of repeaters. I probably should have built this a bit more intelligently. And then we need red glass towers. Okay. Now, if we power this bottom one, because I have red wool right there. If we power this bottom one, then that should reach all the way to the top and cancel out this result. So the way to deal with this is if I quickly just steal all of this. Oh, great. There. That's a bit silly. And then I just need to stand here, so hit copy, / paste. Yep, that goes well. Paste, and finally paste. So we keep all of them powered, and then we unpower based on the set of inputs. So we're just going to do this. So currently both of them are knotted, so this can go through. Then we need to make a different one here, and a different one there, and a different one right here. So in this case, we want both of them to be off. Here we want one of them to be off, the other to be on. So we'll probably do that. Here we want the other to be off and the other to be on, so that'll be that. And then here we want both of them off. On. Yeah. This does not work. What did I do? Oh, I'm an idiot. Okay, well, you got the picture. I hope. Okay. And then we just need to connect up those signals. Maybe I can grab some purple wool. What if I do this? Where I have the output be here. So I quickly need to check what value is coming out of this one. That would be a 15, 15, 14, 13, 12, 11, 10, 9. Oh, wait. Ah, great. Okay, so that doesn't quite work. But I can move it to like there, probably. There we go. Then connect those up. Just need to make sure that every signal is capable of reaching the end. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So repeater there. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4. Excellent. Okay, then in this case, this would also be 15, so that is going to make it. This one would be 13, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Great. Okay, and then this one will make it. So it'll look like that. Then we can duplicate that. Stack 7. Same deal. Okay, excellent. That's all that done. So then this is where the output will be. So I'm going to quickly build the output. Okay. And then next to that, I get to select the operation. How about that? Okay. And then we travel back to here. Make this red. I can just do that actually. Okay, that's ugly as hell. Okay, so that goes there. And then this signal goes down here. Okay. Do they reach? They do. Excellent. Okay. So now if either one of them... wait. No, this is not right. Because now all of them are... Only the back one is enabled. Yeah, okay. So we're going to have to invert all of these. So the easiest way of doing that is this way. Please make it. Nice. Okay. Cool. So now only this one should be disabled. And now only that one's disabled. Okay. Interesting. Did we do that? I think we do that. So this one becomes an AND. So we can turn this into these. Like that. So now because both are flicked, only that one is disabled, which means that now the result should be an AND. Indeed it is. Okay, nice. So now if I flick this to OR, then we should see that. Yeah, that seems to be correct. Okay, and then this one. I don't know which one I just activated, to be honest. Okay, that's backwards. Okay. Whoops. So this should be a repeater. And this should be a torch. And this should be like that. And this should be, again, the other way around. That better make it. Okay. So this should be the NAND. So not AND. So the way we see that is only if they are both on is it off. And that is almost correct. Why is this one wrong? You're joking. You're actually joking. 13? Why is that 12? That's a bit strange. Why is this 12? 12, 13. Ah. Okay. Alright. That's upsetting. We'll just do this. There we go. That way we know for sure. So this is NAND, and then here we have NOR, which of course is only on if neither inputs are on, which is also wrong. So it should be on, off. And then... Oh, wait. This is correct. Is this correct? Really? Yeah, it's only on if both are off. Yeah, okay, this is correct. I'm an idiot. Okay, nice. So that's that. And then we can OR it back. We go back to OR. It takes a second to correctly update. But this is it. That took an hour. Nice. Right. Because these are getting longer and longer and longer, because these contraptions are getting bigger and bigger and bigger, this is where I'm going to leave it. I will leave the registers, I will leave for next episode, and hopefully next episode, Joshua will be back. But we are really getting super close. If I quickly switch over, we are getting really close to a working computer, which is really cool. We just have the CPU architecture left, which is the big complicated part, and probably we won't be able to do the full thing because I'm guessing that the working computer will be more complicated and require more bits than we have access to in Minecraft. So we might have to downscale the working computer. But for now, we have a working logic unit. Logic engine is what it's actually called. So after this, we have arithmetic engine, which is, I believe, an ALU. And then we get into some cool... Yeah, we get into some cool stuff. Okay, nice. So we have registers and we have arithmetic engine next time. Cool stuff. All right. Thanks everyone for watching. I hope you found this interesting and educational. And hopefully you understand logic a bit better. That would be great. And hopefully you understand Redstone a bit better. I hope I properly explained everything for you guys. And yeah. Hope to see you next time.